Hello and welcome. So, for the problems we have here, we're going to be finding all solutions to the equations. Alright, we should have exact answers, so no decimals. Alright, let's get right into it. So, first off, let's look at this problem on the left. We have 81v to the third minus v equals 0. Now, if I want to simplify this, what this ends up looking like, if we want to start solving it, there's a couple of ways you could try, right? First thing that I would look at is I'd say, okay, quadratic formula is not going to work. It's not a square, right? It's a cube right there. So that's out of the running. Okay, can't use square roots because, again, cube, that's a problem. Which means your really only best option to go about this is to try to factor. Well, if you're factoring, what's your first step to factoring? GCF, right? We'd say, okay, is there something in common between our first and second term? Yeah, there's a v in common, is there not? Right? This term has three of them. This term has at least one of them. That is a v in common, which means when we pull it out, right, if we have three v's, we pull one out, there should be two left. And here, if we have 1v, we should pull the 1v. Now, does that mean that the whole term is gone? No, right? Technically, it's negative 1v there. The v may be gone, but the coefficient still remains, all right? Make sure you don't accidentally do any extra. Okay, so if we look at that same idea on the problem off to the side, we have that exact same thing going on where there's a z there, and we can pull a z out, and we're left with z plus 6, right? 1z, two z's, take one out, one left, 1z, we take it out, there's just the 6, equals 0, okay? Now, the difference between these is essentially the exponents, right, and the numbers, but the exponent's the biggest difference, is that here we have a square, here we don't. On the left side, that can continue factoring. On the right, it cannot, and the reason is the exponent. If there is no square, you cannot continue factoring. That is the end, right? Versus if there is a square, that can continue factoring. Don't stop. Okay, there's two ways you can do about it. So 81v to the second minus 1. If you want to factor this, there's two ways. If you remember the shortcut for what we call differences of squares, use the shortcut, right? If you recognize that 81 is a perfect square of 9, 1 is a perfect square of itself, and subtraction in the middle, right? V is a perfect square, v squared, perfect square of v, right? That's everything you need for the shortcut. We know factoring ends up with those two parentheses, right? We take one of our 9s, we share one each. We take one of our v's, we share one each. We take one of the 1s, we share it each, plus minus. There's your difference of squares. Alright? Or, if you don't remember that shortcut, you could take 81v squared plus 0v minus 1, and then you can factor, right? 0 in the middle, negative 81 in the bottom. That'll be 9 minus 9. So 81 v squared plus 9v minus 9v minus 1. And then factoring by grouping will take you to the same place. So 9v plus 1, 9v minus 1. Okay? Either way, now it's factored, right? So on the left side, now we have our v on the outside, 9v plus 1, 9v minus 1 equals 0. Now, where do you go from here? Is once you finish factoring, remember, after you finish factoring, you gotta set each factor to 0. Factor meaning everything with a variable is a factor. So here's factor number 1, set it to 0. Right? Here's factor number 2, set it to 0. Here's factor number 3, set it to 0. Alright, and then solve for the v. On this first one, v is 0. Literally, there's nothing more you can do. 0 is a solution. Okay, on this one, we can subtract 1, both sides. 9v equals negative 1. Divide by 9 to undo the multiplication, right? 9 over 9 is 1. V equals negative 1/9. Negative 1/9 is your next solution. Same thing with this one. Instead of subtracting the 1, we can add the 1 to undo subtraction, right? 9v equals positive 1. Undo multiplication with division, and we get 1/9 as a final answer. Okay, versus this problem over here was already factored, right? So we set our first factor, z, to 0. We set our second factor, z plus 6, to 0. Alright, 0 is already solved for in our first factor, nothing to do there. Versus this one, minus 6, and you solve for z. Z equals negative 6, so negative 6 is your second solution. Okay, so be very careful. The powers are what you have to watch out for. If there's a power larger than 1, in other words, exponent of 2, right, something like this is happening, you gotta keep factoring. Versus if it's a power of 1, it doesn't factor further. Alright, thanks for watching.